So we were discussing the architectural design last time, and we discussed the need of architecture, different styles, and the patterns which will fit in those styles, and patterns which are more restrictive than the styles. So we have something called archetype, which is like a class or a small part of the system, and these archetypes are quite helpful in defining the system in detail. So we will see what is archetype soon. In the architectural design, we make different components, and as the system would be talking to the other devices which are not in our design, that means those are already in existence or may come to communicate with our system. In that case, we have to make our system in such a way that the developed system would be able to communicate effectively with all external devices or components. So in the given context, there may be different category of the devices. Few may be the subordinate systems which will be used by the developed system and provide data or processing to complete the function. There may be some superordinate system which will use the developed system for completing the processing or the functionality. We may have few peer level systems which would be interacting with the developed system, and we would be having few actors or users. So if you see this diagram, we have our system in between, which is our safe house security system, and we have the safe home product and internet-based systems which will be using the target system for the functionality. So they would be, both of them would be superordinate system for the target system. We are having the surveillance function, which is interacting with the target on equilibrium basis, and target also interacting with the surveillance function, and they are on the peer basis. We have the homeowner, which is the user of the system. The control panel also sharing the information and consuming information from the target system, so that would be considered as actor. And sensors would be used by the system, so they may be considered as the subordinate system. So in a design, when you would be checking the context of your system, you have to check what type of external components may exist, and the system must be interacting with all of them effectively for a better integration of the ecosystem. Let's see the archetype. As we were talking, archetype is a small unit, maybe a class, maybe a small component, and this will help the designer to see what kind of details will be needed later. And as you would be knowing now, design is an iterative process. We are making higher level design, than detailed design, and then very detailed design for the coder. So at each level, in each iteration, we add more information. So archetypes will give you some information in the beginning, and later we can have more details in that. So if you are going to design a system, how you will find these archetypes, or how you will decide which archetype I need to make, from where you will get the internal details of archetype. For this, if you are planning to use structured modeling, in that case, you would be already having the DFDs, data flow diagrams, from requirement analysis, and you have to check details of DFDs and have to bring the information of archetype which you have to make in detail. If the designer is planning to use object-oriented approach, in that case, the class diagram which are defined in requirements model and these archetype would be defining the behavior of that particular component, and all these archetype would form the behavior of the system. So here you can see we have one controller, one node, detector, and indicator in the archetype. The node is a collection of input and output elements of the security function, and node would be having the functionality to collect some information and to deliver some information in different formats. If you see, there are two classes below, detector and indicator, which will be used by the node. The detector and indicator both may be as sensors in the hardware. The detector may be the abstraction that different kind of sensors would be sensing something and feeding to the target system, to the security system, while indicator may contain all methods or all functions to show something, to indicate something like LED, lightning, beep, or something else. Then we have controller. It may be inside the system or may be outside the system. The node can talk to the controller and can behave accordingly. Now we would be having the refinement of these components. So after making the basic component, there may be few subordinate system or superordinate system which would be functional and showing the behavior. But there would be few part of the system which would be static and would be very important, although there would be no functionality visible by these. For example, memory management in the system, traffic load balancing in the system. So these would be there. Also, in each component, there need to be some external communication modules. Here it is given as external communication management, and that would be responsible for communication with the internet-based system or alarm notification or any other external data transmission. Then we have control panel processing, which manages all control panel functionality. Detector would be handling the sensors and would be responsible for collecting data and detecting the abnormal situation. An alarm would be responsible for generating alarms if the conditions for alarm are in the system. So this refined model, which we have added the extra components in the component diagram, we have added the extra behavior, you can say we have added few details. So in each iteration we will add few more details in the diagram. So the behavior and the functionality should be clear to everybody, and there should be less space for the ambiguity. So this structure which you are seeing on the PPT, this is in UML, although UML is not a 100% architectural language, but as you have used UML and you understand UML well, so in this book, Pressman, in PPTs and also in object-oriented design, we prefer UML for architecture description. All these information would be managed by Safe House Executive, which is at the top of the diagram that shows the top to down flow of the design. Now, suppose we can make a basic component structure for a given problem, requirements by the client, and this architecture which we are having currently is very abstract, although it is correct, it is right, but we are not having much information on that. So we will find some archetype, and these archetype we will add more details, we will refine the architecture, and we will add some more details, and probably you may get the structure which you are seeing currently here on this slide. Now, how we can apply this to the big problem which are there, because this is abstract and the problem is big enough. So should we say the design is correct and let's implement it and we should give this to coder? It is possible something is wrong with the design, or not everything is accurate as per the requirement. Can we do some testing of a small component? So for this purpose, we create the instance of the design. Like in object-oriented programming, you have a class, and when you create the instance of a class, few variables would get copied there. You can initialize those values, and also you can access the methods. So in this situation, in design, we will create an instance of the design, and that instance we will try to fit on a very small part of the problem, and we'll check if that problem is getting solved by this design instance. If yes, our design is correct, and we can probably check other part of the problem. And if you have time and if you have resources, you can check all parts of the problem in pieces, and if everything is working, your design is active. So the slide you would be seeing, this is the instantiation for the safe home architecture, which is our case study. You already have the document for that. And this instantiation of the design for the security system component in the architecture. So here we will add the minute details to check whether the behavior of the selected components would be shown by the design. So in the last figure, in the refined model on last slide, we added few components which we call extra details, and here we are further elaborating them to make sure that the behavior of the small component performed by the design. So the detector component is interacting with scheduler, which you can see, and the scheduler would be interacting with the sensors and maybe doing the polling of the sensors to check which sensor has a new information, and probably that information may be useful for the system for some critical event, and we should pass it. Now the sensor is a hardware which probably you have to buy or you will get from the manufacturing unit if it is in-house, and that is not further divisible. Now we have a situation where you created the instance, and let's say you did check all parts of the system based on the requirements, and somehow they came valid, that means your design was valid, it was correct, and you went ahead with the design. Now, before completion, the resource manager, the person who is funding the project, that person is interested in validation of the process, that you have done 40% completion of the project. Can I see that everything is on track? You can say that everything is on track, but how you will prove it? Unless the system is working and this is complete, we can't say one module is working. And this is very common everywhere. If you are building a house, you can see, okay, there are 2 rooms which are ready and we need more structure, so something is on the ground. And this is a tricky situation in software development, because if something goes wrong, the whole process you have to iterate from the beginning, and that would be very costly. So SEI, we call it Software Engineering Institute, which is a big name in the software engineering. They have developed an architecture trade-off analysis method, which are 6 steps to iterate that if something goes wrong, you can follow the steps and iteratively. So collect scenarios from the requirement analysis. As I said, if you have plan to use object-oriented design, you have to collect these from the class diagram, requirement analysis class diagram, and if you have plan to use a structured design, you have to get the scenarios from your DFTs. Second step, check the requirements, constraints, and the context. Describe the style or pattern, whichever you are planning to use, or the pattern in the style. And then you have to check the module view, the process view, and how data would be flowing. The data would be going from inside to out, out to in, and within the system. In the design of components, you must have a very clear definition and very clear idea how the data would be going from one place to other place. You can make a component, you can make a module somehow, but the interaction with others must be perfect. Step 4, evaluate quality attributes while considering them in isolation, whether they are performing well. Step 5, identify the parameters which are getting affected by some variation, maybe because of external thing or maybe internal thing. So we have to check the quality of those attributes in the architecture system, and if possible, we have to tweak them for better performance. Finally, do the detailed analysis of candidate architecture, which we developed in step 3, using the sensitivity analysis which we did in step 5. And you can follow this process in few iterations to see if you get some performance improvement in the architecture. Okay, we have the language here. This is the architectural language. We also call it architectural description language, ADL. They provide semantics, sometimes code, and maybe visual diagrams for describing the architecture. So using the ADL, the designer can decompose the architecture into different components, as we were doing using UML. The designer can compose different components and can make the large architecture or the different blocks in the architecture, and can represent interfaces, internal and external, among components, and that can also be validated using ADL. So there are few popular languages, the first one is Rapid, which is a quite popular one. Then we have Acme. This is also quite popular one, considered as second generation language. And we have Unicorn, which is quite useful while you are describing the structure in abstract format. And your favorite is UML here, and UML was not an ADL, but nowadays it is quite popular, so we can use it, and it will not give you the full functionality for architectural development. So I would suggest you to check either the UML in detail, because you have to do the designing in this, and also see either Rapid or Acme, because these are two popular one in the industry. Here, I'm assuming that all of you know very well what is DFT, how to make a DFT, and how to interpret it, which probably you have done also in assignments. If you have to get the information for the architectural design from the DFDs of customer requirements, we call it the structured approach or the structured design, and this is mostly based on DFD, and we have to refactor the DFDs to get the information of different components. So I would suggest you to go through this section yourself, because you know what is DFD, and you also have the case study of the safe house. So get your DFD and try to divide this and try to make the architectural diagram for the safe house. You can see the section 9.6.1 from the Pressman book. So if this is a different chapter in your book, you may have a different edition. So this is chapter number .6.1 section in the book to see how to divide the DFD to get the particular component. Although if you are not looking at the book and you are doing this yourself, you may come with a design, and that would be also correct. So how a person is decomposing the information, decomposing the DFDs, that may vary. Now, another quite important question is that we have different DFDs or different information, and we need to divide them into pieces in structured design. And why we should do this? In object-oriented, module is one necessary thing, and the design would be modular. So in object-oriented approach, this question is not there. While in a structured, we have to find this. So the answers are quite obvious. If a big architecture has been divided into small pieces, it's easier to test, easier to maintain, similar as modularity benefits. Side effects would be few, and results in software extendability would be easier. So we would also like to have the module concept in the partition, and we call it here the small piece. There in object-oriented we call modules. So structure design, as we were discussing, the approach is you would be having DFDs. The DFD you have to map on the program architecture. The PSPEC is process specification, and STD is a standard. They are used to indicate the content of each module, and you have to show this in a structured chart. So as I suggested, you should check section 9.6.1 to get the details how to analyze the DFD, as you already know the DFD. So we generally isolate the transform center by checking the incoming and outgoing flow boundaries to see where data is flowing, and then we do different kind of factoring, first level, second level, and if needed more, and generate the map. So from the DFD you will get this kind of chart, and you can see here that this is a call and return style which they have used in this structure design.